there, and welcome to part 1 of my automated build system series, where we're building a fully functional, hands-off build system using Docker and Jenkins, all in Azure. In this first installment, we'll be setting up Docker in Azure on a Linux VM. There are several ways to accomplish this, and I'm only going to walk through one possible way to do this in this tutorial. After we get the system up and running smoothly, I will explore other options for setting up the base system, such as using the command line interface. I know Microsoft recently announced that Windows Server 2016 will include Docker, and that is awesome. I'm very excited about Docker being truly cross-platform, and after we get this build system running smoothly in Linux, I'll explore expanding to Windows as well. Let's get started. Alright, here we are in the Azure portal. First of all, we're going to set up the VM. We search for Docker. Several options appear, and wow, Docker on Ubuntu. Seems like the obvious choice, right? That's ultimately what we will be setting up. Unfortunately, it's not that simple. One problem is that it only allows you to select the classic deployment model, and it also doesn't set up Docker for TLS in a secure manner. So yes, we can live with the classic model and we can configure secure Docker ourselves, but there is a better option. Let's go back and search for Ubuntu and choose the latest long-term support or LTS release, currently 16.04. Alright, the deployment model is Resource Manager. Click Create. I'm going to name this VM Docker Build. Okay, one thing to note here is that you can save some money if you choose HDD or magnetic disk instead of solid-state drives. Choosing HDD here opens up possibilities of cheaper plans, which we'll see in the next step. Our admin user will be Docker user, and we're going to use SSH public-private keys to communicate and not username password. Alright, let's flip over to our terminal to create the public-private key pair. SSH keygen, type RSA, bits 2048, and C is just a comment that will be placed in the public key to remind us what this key pair is for in case we forget. We're not going to add a passphrase, and we're going to name the files so that we have a clue as to what they are for. I still want them in my .ssh folder. I'm going to name it id underscore docker build underscore RSA. Enter. Okay. Now let's add this identity to our SSH agent so that it's usable on our system. First, we'll check to see if the agent is running with eval. Okay, yep, it's running. We returned a PID. So now let's add the ID. Great, the identity was added. Okay, finally we need to copy that public key to the clipboard. I'm on a Mac, so I'm using pbcopy. If you aren't on a Mac, you can open the key in a text editor or simply cat the contents out to the terminal screen and copy from there. I'm going to use pbcopy. Now, back in the browser, I'm going to paste in that key. You can see our comment here. We're going to create a new resource group and name it Docker Build. I'm in Seattle, so I'm choosing West US as the location. Alright, everything looks good. Click OK. Alright, here we need to choose a size or a plan for our VM. I'll click View All. You'll notice that I can't see the A plans. They can be as cheap as $15 a month. This is because I decided to leave the SSD selected In preparing for this tutorial, I found that using the cheaper plans with the magnetic spinning disk made Docker hosts run unbearably slow. So I'll pick the DS1 v2 standard and click select. I'm leaving all the default names here for the storage account and all the networking components. For the past couple of years working with resources in the cloud, I found that I don't care much about machine names or resource names. I used to plan out resources and machine names, even going with themes like Lord of the Rings and Star Wars. Well, now all of the resources are disposable and easily rebuildable, so names just don't matter to me anymore. I'm not going to set up a high availability set either, so yeah, this looks good. I'm going to leave all the defaults here and click OK. Azure validates the build and gives us a quick summary. Yeah, it looks good. I'll click OK one more time, and Azure starts provisioning the VM for us. That took a few minutes to complete, and we're back in the Azure portal. I'll click on Resource Groups, and there's our new group, Docker Build. I'll click on the dots and pin to Dashboard. It's a personal preference. I like to pin the resource group to the dashboard. Let's click on the VM. Then the IP address. I want to remember the public IP address and DNS name for our VM. So I'll open a Visual Studio Code doc over here and take a few notes. Copy the IP address, paste it over here. All right, let's add a DNS name to the VM. Click Configuration, and going to name this Docker Build Sys. Click Save. And now I'm going to copy this DNS over to our notes, paste. I also want to point a custom DNS name at this VM. Later in the series, we're going to get TLS certs from Let's Encrypt for secure HTTPS communication to our private Docker registry. We must have a custom domain to make that work correctly. A quick reason is that Azure domains are secured by wildcard certs, which won't work for our purposes. So if you don't have a domain name, you can go ahead and skip this step, but I'd suggest spending the $10 a year to get one. All right, I'm going to pop over to my name provider and paste this public IP address into the A record for the domain I want to use, which will be dockerbuild.harebrain-apps.com. And I'll copy that over into our notes as well. All right, now we have all our public IP addresses and DNS names. Next, I want to make sure we can connect via SSH to our VM. Let's go back to our network security group. Click Inbound Security Rules. All right, and sure enough, Azure already opened port 22 for SSH communication. How convenient. So let's connect via SSH. We'll use our custom domain name and specify the port. All right. While we're in here, we're going to grab the local or private IP address. Let's type in ifconfig, and we're looking for Ethernet 0 adapter INET address. Here we go. And let's also copy that into our notes. Cool, we can exit out of our secure shell session. Let's pop back into the Azure portal. We need to open a few more ports for our system to work correctly. All right, we are still in the network security group, inbound security rules. I'll click add up here at the top. The first rule we're going to add is for web HTTP access for our Jenkins server. HTTP is a pre-configured service, so we can pick from the drop-down of services. Let's name this allow HTTP. Click OK. Next, we're going to add a secure web or HTTPS communication. Again, select from the service dropdown. We'll call this allow HTTPS. Click OK. Once again, Azure does its thing. And finally, we're going to open a port for secure Docker TLS communications. We'll call this allow Docker TLS. And since this is not a pre-configured service, we'll have to make a few more choices. TCP is a protocol, port 2376. That looks good. Click OK. All right. Let's go back to the Azure portal home just to be clean here. There we go. We have one more piece of business to take care of before we install Docker on our VM. Docker uses TLS with client certificates for authentication to communicate with remote hosts. Our Docker host daemon will only accept connections from clients authenticated by a certificate signed by that CA. So we'll create our own certificate authority, server, and client certs and keys. For the sake of organization, we're going to create a local folder to hold our CA and certs. All right, let's make this directory TLS build and move into it. Okay, first we're going to create the certificate authority key. Next, we'll create the certificate authority itself. All right, now US, Washington, Seattle, Harebrained Apps LLC. I don't care about an org unit. Enter my fully qualified domain name here of harebrainedapps.com and my email address, steve@bargeld.com. Okay, now that we have a certificate authority, we can create a server key and a certificate signing request, CSR, and with these we will create our server certificate. Make sure that the common name or CN matches the host name you will use to connect to Docker. In my case, that's my custom domain name. And now for the server signing request. All right, we have one more thing we need to do before we can create the actual server certificate. Since the TLS connection can be made via IP address, even between machines in the private network, in the public IP address, even localhost, in addition to the two DNS names we have, we need to specify all of these options. This is done in a certificate extensions file. We will just echo the options out to that file. And finally, we will actually create the server certificate. All right, the server side's done. Now for client authentication, we will create a client key and a certificate signing request, which we will then use to create our client certificate. Create our CSR, OpenSSL. Subject this time, the common name is client. Okay, to make the certificate suitable for client authentication, we'll update the certificate extensions file. And finally, we will create our client certificate. Okay, after generating our client and server certificates, cert.pem and server cert.pem, we can safely remove the two certificate signing requests. In order to provide a little bit of protection for my keys, I want to remove write permissions and also make them only readable by me. So change the file mode, here we go. The certificates can be world readable. They're basically public keys, public certificates. But I usually remove write access anyway, just to prevent accidental damage. I guess this is as good a time as any to say this. Anyone with these keys can give any instructions to your Docker daemon, giving them root access to the machine hosting the daemon. Guard these keys as you would a root password. Now we are ready to install Docker in our VM. Okay, back in the Azure portal, click on Docker build, the resource group, Docker build the VM, extensions, and add. We want, yep, there it is, Docker Microsoft, and click create. You can see we've already done the prep work necessary here. We opened port 2376 and we created the certs and keys we need. Okay, select the certificate authority. There it is. The server certificate. Okay, the server key. Okay, looks like our choices check out. Let's click OK, and Azure will go off and install Docker in our VM. Okay, you can see here the provisioning succeeded. Let's connect to the Docker host we just created. Flipping over to terminal. All right, we're in the TLS build folder, which houses all of our certificates and keys. It's going to save us some typing. We're going to use a TLS verify flag with Docker and also tell it what CA to use and what client keys and what host to connect to, including the port. Once we do all of that, we can run any Docker command on the remote host. Let's simply get the version info. As you can see, Docker gives the client and server version information, both running Docker 1.12.1 with API version 1.24. All right, let's try to run this without the TLS info. Yep, there we go. We get an error and we can't connect. Docker is even so helpful as to suggest that we're trying to connect to a TLS-enabled daemon without TLS. That's pretty awesome. Now we really don't want to have to send in the 4 TLS flags every time we want to connect to our remote host. So we'll put our CA and client certs and keys in a location where Docker can find them. So let's make that directory, make sure it's there. Let's copy. All right, let's do a Docker PS. And as you'd expect, there are no containers running or stopped on our new install. Images, and no images. It'd be kind of weird if there were images out there already. Let's fix that really quick. We could SSH into our VM and run a local command like docker run. But what fun would that be? Let's do this remotely. We went to all this trouble to set up TLS. Let's prove that it works. Exit. All right, you can see that Docker is pulling a Jenkins image to the remote host. If we fast forward a bit in time, let's see if we can access Jenkins on our Azure server. back in the browser, open a new tab, and we're going to go to there it is. Jenkins is up and running in a Docker container in a VM in Azure. But since this really isn't the Jenkins image we want, we'll clean up a bit. And just to show that we can do things locally, we will SSH into our VM and clean up a little bit more. Okay. Images, you can see this Jenkins image is here. It's Docker RMI. To remove this image, let's grab that image ID. Okay, it's gone. Docker images. Yep, it's gone. So there we are. We're all cleaned up, nice and tidy. In the next installment, we really get to the meat of our automated build system, using our own custom images for our Jenkins master and setting up ephemeral Jenkins slave nodes. What I mean by that is Jenkins will spin up Docker containers as build environments that only get started when a job needs them. So if you need a Java build environment or a .NET Core environment, Jenkins will start a Docker container to handle your build. Exciting stuff. See you soon.